Alrighty, good morning, good afternoon, or good evening, depending on when you're watching this. We are finishing up our conic sections unit, all right? We have 2 days of word problems. We'll do a review, and then there'll be a short quiz. So we're on worksheet 7-7, okay? We're gonna be using this for the next 2 days, all right? The first day focuses on parabolas, and then the second day focuses on ellipses, okay? We won't be doing hyperbolas for word problems because you don't see them as much, and the places where you do, they get kind of complicated, so we're going to stick with parabolas and ellipses, okay? So today, right, you guys remember our parabola, our equation, right, is y minus h, I should say k, sorry, k squared equals 4p x minus h, okay? Or it's x minus h quantity squared equals 4p and then y minus k, all right? This is if it's facing up, right, with a positive 4p. This is if it's facing down with a negative 4p. And then this guy is facing opening right with a positive 4p. And then left with a negative 4p, if you remember that, okay? So we're gonna be using those two forms. If it's at the center, which is gonna happen a lot today, then h and k will just be 0, 0, okay? So that the vertex will be at the origin. Now, parabolas are used in many applications, okay? One of the properties of a parabola is its reflective property, okay? So oftentimes you will see parabolas in when you look at the shape of a light bulb or, you know, some sort of lighting apparatus, whether it be, you can hear searchlights, flashlights, right? Automobile headlights, all right? I have an example here, right? This is a light bulb. If you take a look at this shape, this is created so you can screw it in, but if you can just look at this, this kind of looks like a parabola, okay? And what they're saying here in this question, right? A paraboloid of revolution. Basically, there's a parabola here, and the axis of symmetry, it is rotated around the axis of symmetry, and that's what creates a three-dimensional, like, parabolic shape, okay? So we're gonna have that for both our flashlight here and our satellite dish. So if you take a look, right, the reflector of a flashlight is in the shape of a paraboloid of revolution, okay? So that just means they've taken a parabola, and you'll see some sketches of this, okay? And they've turned it into like kind of like a cup-ish shape, if you will, okay? We have the vertex down here, right? The axis of symmetry would be right down the middle here, and they've just rotated it around, okay? They said the diameter is 6 inches, okay? And the depth, okay, from here to the center, right? That would be your depth, is 2 inches, okay? And when you have, right, it says up here, if a light or any other emanating source, okay, is placed at the focus of the parabola, all the rays emanating from that light will reflect off the mirrors, okay? So if I have a focus here, and I put the light there, right, if it flashes off here, all the light comes and flashes against all the rays, right, that come off that focus, which is where the light is, and then they all rebound off this mirrored surface of the parabola, and then they all come out. So that's what kind of gives you that really bright flashlight, all right? So what they want to know is how far from the vertex should the light bulb be placed, and that's basically asking you to find the focus, okay? Because the focus is what's going to give you the ideal place to put that light bulb, okay? So that the rays will reflect parallel to the axes, right? So this is my axis of revolution for the parabola, so we want all the light to come off that way, all right? So basically, I need to find my focus, okay? So if you take a look here, here's my parabola, right, on the outside here, okay? So what I'm gonna do is I'm gonna put my axes right here and write down that axes where they revolve the paraboloid, okay? And you're gonna have a center, or now a vertex at 0, 0, okay? Oops. So if it's at 0, 0, right, and the parabola is facing up, this is gonna be x squared equals 4py, okay? Because there's no hk, so you're not adding or subtracting any values to x and y. And then we just got to find 4p. Now, you cannot assume that this is the lattice rectum, okay? This is just an arbitrary diameter that they gave us, okay? So what I do see, though, is if this has a width of 6, and this is the dead center where they rotated the parabola, then that means that this has to be 3 inches by 3 inches. So therefore, this point here on the end of my parabola, right, is 3, 2, and then this would be negative 3, 2, right? And that's a point on the parabola. Now I know the parabola should have this equation. The only thing I need to do is find 4p. So I'm going to plug in either one of these points to find 4p, okay? So this will be x squared, right? And then I need 4p, sorry, x squared, x is, what, 3? Equals 4p times 2, okay? So that's how you can write the equation given a point. Now, at the end of the day, what are we trying to find? We're trying to find the focus. Well, the focus is where, right, is going to be the distance from the vertex to the focus, right? That's going to be a length of p. So in this equation, right, and not in every equation, but in this equation, I'm looking actually for the value of p. So I need to find p, okay? So, but the equation is going to help me do that. So here we have, what, 9 equals 4p times 2. So what's this? 9 equals 8p. So divide by 8p is 9/8, right? And 9/8 is, I do that in my head, but I'm too lazy. What is it? 9/8. Oops. 1.125, okay? So if you look, how far from the vertex should the light bulb be placed? Well, if I have at 0, 0, that's my vertex, right? I'm gonna go up, it's going to be 1.125 inches from the vertex, okay? And that's our answer, okay? So that's what we're looking for. We could have also written the equation, which we'll do in just a moment, okay? Not this question, but the next one. So now if you take a look here, a satellite dish, right, is shaped like a paraboloid of revolution as well. The signal emanates from a satellite strike from a satellite strike the surface of the dish and are reflected to a single point. So now with a satellite dish, right, that we have here, we have this shape again, okay? This guy is 10 feet across, and its depth from the center, right, it's gonna be 4 feet. And now what's happening here is they instead are receiving information, right, to the satellite, and then it's gonna bounce off the walls of the parabola and hit and come back to that focus, okay? So then if I have another ray, right, it comes in here, signal I should say. So it's all gonna come into where that focus is, and that's what's gonna receive all the information, okay? So it captures it in that parabola. So if I take a look here, right, it says where the receiver is located. So this is my receiver. Okay, where the focus is. So at what position should the receiver be placed? So again, they are very similarly, let me move this over a little bit, asking us for where is the focus located. So we need to find what position is a receiver, find focus. Okay, so what we're gonna do here is, similar to what we did before, we can put an axis right here and put our center, or our vertex I should say, at 0, 0, okay? So it's gonna be facing upwards the way I drew it, so it's x squared equals 4py. My point, right, since this has a width of 10, this is gonna be located at 5, 4, and 5 comma negative 4, all right? And then I'm gonna find p here by plugging that in. So I have 5 squared equals 4p times 4, so that's 25 equals 16p. So p is 25/16, which, as a decimal, that's 1.5625. Okay, so the receiver is going to be 1.656 inches. Oh, feet, just kidding. Feet from vertex, which is the center of the bottom of the parabola, okay? So that's what we got for that guy. So these two, both looking for you to find the focus, okay? Now let's take a look at the next one, okay? So these have two bridges, okay? So if you think back, right, to the Golden Gate, probably one of the more famous ones, right? We also have, I think the Tappan Zee is also a suspension bridge. Well, at least it looks like one to me, because of the cables. But we have the cables of the suspension bridge are in the shape of a parabola, right? The towers supporting them are 800 feet apart. So let's see, we have a bridge, right? There's my parabola, right? I have a vertex there. Here's the two towers. So those are 800 feet apart, and they are 60 feet high. Okay. If the cables touch the road surface midway between the towers, what is the height of the cable from the road at a point 250 feet from the center? Okay, so I'm gonna, hopefully this is screaming to you that we should put our axes right dead in the center, because they said here midway, right, it touches the road surface, so that's our road right there. So this, our vertex, is at 0, 0, okay? And then, since, similar to what we were doing earlier with our, headlight and satellite dish, this cuts right in the middle. So if this is 800 feet across, right, then this would have to be 400 comma 60 and negative 400 comma 60. So if I translate that onto a coordinate axis, that's what it would look like, all right? So again, similar to what I had before, I'm working with, right, the basic equation with an x squared. I know 4p should be positive when I plug it in. And then eventually they're gonna ask me, they wanna know what the height of the cable is, 250. So that's like here-ish, a little bit past the middle, like somewhere here. What's the height? So I'm saying when I go 250 feet from the center, because remember this is 400 feet from the center, right? So that's my x value. So when x is 250, what's my height? That's what I need to know, all right? So they're not looking for the focus now, they're looking for a y value. So if I have an x value and I need a corresponding y value, I need an equation. So our goal here is to write the equation first, all right? So the first thing I'm gonna do is plug in the point that I know, okay, just like we did before. But now I'm not going to solve for p, I'm going to solve for just 4p. So when I go and do this guy, I've got 400 equals 4p, 400 squared, equals 4p times 60. So 400 squared, right, is 160,000 equals 4p times 60. And I'm just leaving it like this because I'm just going to solve for 4p. Okay, I'm just going to leave it in terms of the equation because I need the equation to eventually answer the question that they're asking me. I don't need the focus. So therefore, I'm not solving for just p. So divide by 60. Ugh, that does not come out to be a very nice number. So that reduces to 8,000 over 3 equals 4p. So I'm going to leave it like that because the decimal is like this 2.666.6 repeating decimal, and I don't want to have to work with that. So I'm going to leave it as an improper fraction. So therefore, my equation is x squared equals 8,000 over 3 times y, okay? Now, if I go to solve here for 250 feet from the center gives me a height of what? Okay, so that's what I'm looking for. So if I go across 250, what do I get? So I'm going to go ahead and plug in 250 for x. So 250 squared equals 8,000 over 3y, okay? So 250 squared, that gives me 62,000. 500 equals 8,000. Now you could do this one of two ways. I'm going to multiply by 3, then divide by 8,000, and that gives me, right, 23. So y equals 23.4375, okay? So if you think about it, right, 400 is at a height of 60, right? 250, right, we should be increasing, but remember it increases much faster as you get towards the end here. So 250 at a height of 23, 24-ish feet, that seems reasonable, okay? So this is our height there, okay? So we first had to write the equation, then we had to plug in, okay? Similar idea to what we're gonna do here, okay? So be careful here when we do this guy. This one is in a parabolic arch, okay? I have to tell you if it's a parabola or what you're gonna see tomorrow is that it could be elliptical, okay? But a parabolic arch bridge looks like this, okay? So this is my parabola, right? And you may have seen these. I think there's a couple on the Merit. They might not be a parabola, but it kind of looks like this, right? And then there's usually a road up above and you go through it, okay? And it says the bridge span is 120 feet with a maximum height, the highest it is, right, is 25. Okay, and then the span, right, is 120. Okay. Oh, I don't know why I put degrees. That's crazy. Okay. So this is feet and feet. Okay. So now if I do similar to what we've done before, right, and there's more than one way to do this, okay, I'm going to put my vertex at 0, 0, okay? And this guy, right, is still opening up or down, but now when I plug in, I should get a 4p value. That's going to be negative. So this should be negative if I do all my points and everything correctly, okay? So that's a good check, all right? I'm not going to make 4p negative. I just know it should end up to be negative when I plug in my values, all right? So when I go to find my point, right, this guy, right, will be 60, won't it, right here? And then if this is 0, 0, I went over 60, but I went down right? Didn't I? Negative 25. And then here I did negative 60 comma negative 25. Okay, so hopefully that makes sense to you guys, right? Because we're going to the right and then we're going down, okay? So now when I go to plug this in, right, I'm going to solve for 4p, because if you take a look here, choose a suitable rectangular coordinate system, meaning like, you know, use your normal x and y axes, all right? Place the vertex at an appropriate spot, okay? And then we're gonna find the height of the arch at a distance of 10, 30, and 50. So 10, so we're gonna do this 3 times. I may not do it all 3 times. I'm probably just gonna do the 10 and the 30. So we're gonna find the height here, right, at 10 feet. So 10, right, from the center, and then the height. And then we're gonna go here, and we're gonna find where it is 30 from the center. What's the height, okay? So let's take a look. So x squared equals, I'm gonna plug in my point, so what's that? 60 squared equals 4p times negative 25, so what's that? 60 squared is 3,600 equals 4p times negative 25. I'm again solving for 4p because I'm gonna write the equation. So if I divide by negative 25, which this is gonna be a nice number, thank goodness. So divide by negative 25, and I get negative 144, which is good. I should have a negative 4p value, so that makes sense. Okay, so my equation here is x squared equals negative 144y. Okay, so I plugged in my 4p into my equation, so that's what I'm working with. So now, I use my point, remember it was 60 across, negative 25 down. All right, so now I'm gonna solve here. What's the height, what's the y value? I should say, what's the y value at a distance of 10 from the center? So at 10 feet from center. So we're gonna do this twice, okay. So the height is, okay, so I need, this is when x is 10. I'm gonna do 10 squared equals negative 144y. So that's what, 100 divided by negative 144. So y equals, and that's negative 0.694. Okay, so that's repeating. Okay, so when I go to do this, okay, I'm gonna go here. If I were plotting this point, I would go over 10 and down this. Now, is y actually my height? No, y is the distance from the x-axis that I created here. So that's this little distance from the x-axis to this point. That's a negative 0.694. So my height is actually, from the bottom, is the difference between 25. So the height at this point is going to be 25 minus 0.694. 25 minus, I'm just going to round that, 0.94. And that will give me a height of 24.306 feet. Okay? So you have to, because of where I put the axes, okay, you have to subtract that difference from the total height of 25, okay? Let's look at 30 feet. Okay, so if I'm going a little further from the distance, okay, my height should be smaller, so hopefully I get a smaller number here. But at 30 feet from center, so that's the first one. We're going to plug in 30. So this is when x is 30. So 30 squared equals negative 144y, right? So now I'm going to take 30 squared divided by negative 144, and that gives me negative 0.625 equals y. So again, this distance, when I go to graph this point, is across 30 down negative 6.25. So this distance is negative 6.25. Now it's negative because it's on a coordinate axis, but the distance is 6.25. So that means the height here is the difference. I have to subtract 25 minus 0.625. So then I'm going to get 18.75 feet. Okay, now some of you might want to do this differently. I did this way to keep it consistent with our other examples. You could technically put, change this and put the axes elsewhere, but this is how I chose to solve it, okay? So if you do solve it differently, that's fine, but this is consistent with what we've been doing, okay? And then for the 50 feet, we do exactly the same thing. Plug in the 50, right, which I'm not gonna do, but, and then find the difference between that value, that negative value, and 25 to find the height, okay? I would know it's definitely gonna be less than 18.75 because we're going much closer to the edge here because the edge is at 60 feet, so 50 feet would be much less, so the height would be smaller, okay? So hopefully that is helpful. Try the homework. I posted the answers, I should say the questions on a Google Doc because some of you don't have your textbook. And then there's an answer key of all my detailed answers that you can use to check your answers, okay? Hope you're doing well.